Hello, everyone, and welcome to Mitigating Your Safety Goals with Your Sustainability Initiatives, brought to you by Erlab's virtual event, Safer Labs, Greener Futures. My name is Delia Osborne with Labroots, and I'll be your moderator today. Before we get started with the presentation, I encourage all of our attendees to take some time after the talk to explore this wonderful virtual space, including meet your expert in the networking lounge immediately following this session. I'd now like to introduce our speaker for today, Tim Campbell, Green Fume Hood and Sustainability Manager with Erlab. To view Tim's complete biography, click on the speaker information window on your screen. Tim, over to you.
Thank you, Delia. As Delia mentioned, I'm Tim Campbell. I am with Erlab, and I will be giving your webinar today. Erlab's goal for the last 55 years has been to improve the safety of lab personnel by reducing their exposure to chemicals within the lab space through ductless filtration. So the objectives today are going to learn how Erlab's filtration could deliver a holistic approach to lab safety, understand how Erlab's filtration increases lab safety without the need for HVAC integration or infrastructure upgrades, and then learn how Erlab's filtration can reduce upfront as well as operational expenses and support your decarbonization efforts. Now, with Erlab, everything starts with our ecosystem of filtration. That's how we deliver that holistic approach to improving your lab safety. And everything starts with our capped air ductless fume hoods. Erlab as a company actually invented the first ever ductless fume hood 55 years ago in 1970. Our founder was in France at the time making lab furniture, and he made a shield that would slide along the lab bench that the researcher could put in front of them while they're mixing chemicals. Unfortunately, there was nothing that could be done for the chemical vapors that were being released from their mixtures. Being a World War II veteran, he was familiar with carbon filtration for the gas mask he wore for mustard gas. He was able to come up with an enclosure with a carbon filter and a fan, and basically invented the first ever ductless fume hood in 1970. We've been continuously improving our filtration technology ever since, and everything with us starts with our capped air ductless fume hoods. They're single wall structure. They ship completely knocked down, so they're easy to get into a lab and assemble, get through narrow doors, and there's a short 2-week lead time to get them into your lab and protecting you. And then in 2010, we started partnering with traditional fume hood manufacturers. So these would be the traditional fume hood structures that you're used to using in your lab, which would integrate our most advanced carbon filtration technology. We call that the green fume hood. And then we've also taken that filtration technology from our ductless fume hoods and put it on where you store your chemicals in our filtering chemical storage cabinets. When you store chemicals, open bottles, samples, satellite hazardous waste accumulation containers in a closed cabinet that's not ventilated, the concentration of the vapors builds up. And when you open that up, you breathe it in. I'm sure most of you know when you open one of those closed cabinets, and it smells. So those odors you're smelling are chemical vapors. They're not good to breathe in, especially at that concentration. So our filtering chemical storage cabinets constantly filter the air within those cabinets, capturing any chemical vapors that are released. And then our last product of the ecosystem of filtration is our ceiling mounted halo filtration units, which you can see above me here on the ceiling. They're completely independent from your HVAC, and they use either a carbon filter for chemical vapors and odors or a HEPA filter to reduce overall particulates in the space, such as airborne viruses, bacteria, mold, fungi. So what is a ductless fume hood? Well, I'm sure you're all familiar with traditional ducted fume hoods. They use a series of ductwork, fans, and blowers, basically to evacuate the chemical vapors and fumes that are created in the enclosure. And it just takes them and through that series of ductwork and fans, blows it outside, lets that be the outside world's problem. I guess the solution to pollution is dilution. That's the thinking with a ducted fume hood. With a ductless fume hood, you remove all that infrastructure, all that ductwork, and instead you use an advanced carbon filtration system to capture the chemical vapors and fumes that are generated within the enclosure and return clean air to the lab. That means you don't need to integrate it to your HVAC. You don't need to balance the air. You don't need makeup air. They're very simple to add to your lab. All you need is space and a 120-volt outlet. And what makes Erlab's carbon filtration different than everybody else is that we have universal carbon filtration. That means we have a special carbon recipe through years of testing that will allow you to capture acids, bases, and solvents all with one filter. You don't need separate filters for different types of chemicals. You can use one carbon filter for that. The other thing that makes us different is our flexible filtration column. That allows for the addition of fully redundant safety filters to improve the overall safety of the hood. Also allows you the ability to add HEPA filters in case you're working with any toxic powders or creating any exothermic reactions or doing acid digestion where you need the particle capturing efficiency of a HEPA filter. Our hoods are also equipped with automatic breakthrough detection. So there's a solvent sensor on every hood that's going to constantly monitor the performance of the main carbon filters, constantly sample the air as it passes through them, and will alert you to any potential breakthrough. And that's why having this fully redundant safety filter on the hood is so important. So here's a breakdown of our flexible filtration column. So you can see in the picture on the left, this is one of our more common filter configurations. Now it's about 50-50. But it starts with a HEPA filter. If you are using any toxic powders, having any exothermic reactions within your hood, you're going to have that HEPA filter on first. And then you're going to have that primary or main carbon filter. That is what is capturing all the chemical vapors and fumes that are generated within the enclosure. Above that, you have the fan box. That is what is driving the air away from the end user and up into the filtration column. And that is also where the solvent detector and or acid detector is located. And then above that is the backup carbon filter for safety redundancy. So over on the right side, you can see the different configuration of the filters. It's about 50-50 now, whether it's just carbon filters where you would just need the primary carbon filter and a backup carbon filter on each filtration column, or if you need to add a HEPA filter, again, for using toxic powders or any exothermic reactions. But also that flexible filtration column allows you to install these hoods in clean rooms because you can have the HEPA filter on top of the last carbon filter, and that helps you keep the particle integrity count of the clean room. So basically ISO 7 or cleaner. And when it is time to change the filters, oops, one too many slides. So when it is time to change the filters, you're only going to change half the carbon filters on the hood. So ideally, it's a 2 to 4 year lifespan, depending on the size of the hood, whether it's 3 foot to 6 foot. And on that original picture I showed you with our ductless fumigator, that was a Captive 483 that had 3 filtration columns. So when you first start using that hood, you're going to have 6 carbon filters on the hood. Then ideally, every 2 years, you're going to change out 3 of the 6 carbon filters. So the 3 primary or main carbon filters are discarded. The 3 backup filters, since they're just in the backup position, rotate down to become the main or primary filters. And then the 3 new filters become the backup. And when you dispose of the filters, we recommend high temp incineration. They're basically regulated non-hazardous waste. So you have an on-site hazardous waste provider. They can typically dispose of the filter for you. And if you don't, you can basically just put that filter back in that same box and bag that the new filter arrived in. You put that used filter in there and UPS it back to us. And it's about $75 a filter to dispose of if you go that way. Now on to our filtering chemical storage cabinets, which I mentioned before. So when you have samples, you have open bottles, at-use bottles, satellite, hazardous waste containers in that closed cabinet, that air is not moving. The concentration of the vapors and odors builds up. And I'm sure you know when you open those cabinets, those odors, you breathe them in. That's not good for you. So we've taken that same filtration technology from our ductless fume hoods and put it where you store your chemicals. So you constantly have airflow flowing through the cabinet, past those bottles, pulling the vapors that are being released from those bottles up into the carbon filter and returning clean air into the lab. We also, with our flexible filtration column, you can add HEPA filters. So if you are storing any hazardous or toxic powders, you can increase the safety of that by having the filtered cabinet. We have our own standalone, which in this picture is our 1634. That's our largest cabinet. We have with 4 doors. You have cabinets half the size with the 2 doors. We have underbench ones. And then we also have, since all of you, I'm sure, have yellow flammable safety cabinets or blue acid cabinets on your lab or in your building, we have a ChemTrap filtration unit that will integrate onto those cabinets. All those cabinets typically have a 2-inch threaded port, so you can connect metal tubing from that cabinet to our ChemTrap filtration unit, which has a fan and a carbon or a HEPA filter in it to remove the chemical fumes or vapors that are being released in those cabinets. I used to collect hazardous waste, so when you would open those cabinets and there was a satellite hazardous waste accumulation container in there, the smell that would come out of them was overwhelming. So not only are you going to increase your overall safety anytime you go to open a cabinet, but you're also going to make the lab smell better because those chemical odors are not going to be released into the lab. Now on to our Halo ceiling mounted filtration system. It was designed to add air changes into lab spaces that don't have enough ventilation. So you can either have a carbon filter, it's going to be for chemical vapors and fumes. Each Halo with a carbon filter holds about 130 CFM. So our recommendation is to add enough Halos to add 2 air changes per hour, which comes out to about 4,000 cubic feet of space. So if you have a 400 square foot lab with 10-foot ceilings, you need 1 unit. If you had a 800 square foot lab with 10-foot ceilings, you need 2 units. And then with the HEPA filtered version, that's for particulates. There's less resistance through the HEPA filter, so you have a higher CFM at about 175. So you need 1 for about every 5,250 cubic feet of space to add the 2 air changes per hour. And where would you install them? Well, in the lab world, the carbon filter is kind of easy. The carbon filter version is kind of easy to know. You should install one because you can smell odors. You walk into a space, you can smell odors. You walk into a lab, it smells. There's probably something going on, whether the HVAC's at capacity. You may have equipment in there that's not vented to the outside, where it's releasing chemical vapors and odors into the lab space. You may have hazardous waste storage rooms, a chemical stock room where, there's always odors coming off those bottles. So the Halo is a good option to install in those places to help increase the ventilation effectiveness of your current HVAC, but capture and remove those chemical vapors and odors. And then the HEPA filtered version would be typically in the microbiology world, where you may be having contamination of samples because you may be having fungi or bacteria, mold coming in through your HVAC system. And you're not sure why you're getting those contamination in your samples. It's very costly to upgrade your entire HVAC system. The Halo HEPA unit will help reduce the overall particle load in the air, which will include bacteria, fungi, mold. So they're, very well designed, very energy efficient. You just hang them similar to a light. They're electrically wired in. Each unit only pulls 50 watts of energy. It's going to help improve the overall air quality within your lab space. We also have lots of customers who will install them in offices next to the lab, because sometimes the chemical fumes and odors from the lab space will make it into the office. So they'll have fragrance companies install them in their conference room. The Halo Carbon, just because they'd have meetings and have lunch, and it was hard to eat while you're smelling all the fragrances that they're making in the conference room. Now we're going to go on to the safety behind the filtration. Why Erlab's carbon filtration works. That picture there, that is our R&D lab in France. And you can see they have the whole ecosystem of filtration there. So they are constantly using the our capped air ductless fume hoods, green fume hoods, filtering chemical storage cabins, as well as our Halo units. And in that lab, I don't know if you can see in the picture, there is a glass bubble. This is one of the most important things we have, because this is where we actually test our carbon filters, the design of our carbon filters, and also we test the retention capacity of our carbon filters. So we've tested over 600 different chemicals with each of our carbon filters. So in that glass bubble, we have a ductless fume hood with 1 filtration column, so a main filter and a backup filter. We'll take the chemical we're testing, we'll have an peristaltic pump, we'll constantly drip a known portion onto a dish on a hot plate within the fume hood. That chamber will be sealed and the air will be constantly sampled with the GCMS. And the testing can take a couple hours to a few days, depending on the chemical we're testing, its physical characteristics and its threshold limit value. And we'll sample that air and run the test until we reach 1% of the threshold limit value, or TLV, of the chemical we're testing. So those over 600 chemicals we've tested are 98% of the most common chemicals used in chemistry labs, representing thousands of chemical families. The reason we do this is because we adhere to the AFNOR NFX 15-11 filtration standard. Part of that standard is providing documentation in a chemical listing where you list the retention capacity in grams of the chemicals that can be used with your carbon filters. And part of that testing, or part of the standard, the AFNOR standard, is also that you have to have a filtration efficiency. And for that, with all that testing we've done, we have each customer fill out what we call our chemical questionnaire. This is going to list the chemicals they're using, the types of containers they're in, the temperature they're used at, because that all affects the evaporation rate of the chemicals, the quantity per month, how often they're using it. From all that testing we've done in our test chamber with the carbon filters, we then take the information on this chemical questionnaire, plug into our algorithm, and then we're able to give you a filtered lifetime in months before 1% of the threshold limit value of all those chemicals you're using would be detected past the exhaust of the carbon filters. And that's the most important part of the AFNOR 15-11 standard. And you'll see on this page, this is the feasibility study or the filter lifetime report that you will receive. And it shows the M1, when you see the filter lifetime, stands for 1 module of filtration up to M6, 6 modules of filtration. So as you add more filtration columns, typically the filter lifetime goes up. But on, say, an M4, which is a 6-foot hood, a very common hood, you have a 48-month filter lifetime. So that means while you're using that hood, how you said you would, we guarantee no more than 1% of the threshold limit value of any of those chemicals you're using would be detected past the exhaust of the carbon filters. And then we have the detection phase, and that's where those the solvent sensor or acid sensor in that fan box comes into play. And that is where it's constantly sampling the air. If, say, there was a spill in the hood, you spill a beaker of acetone, temporarily overwhelms that main carbon filter, that solvent sensor will alarm. But by having those backup carbon filters on top of the fan box that add that added safety redundancy, we still guarantee no more than 1% of the TLV will be released past that backup filter. And that's why the importance of the backup filters are so important. And then safety phase would be if you were to have the breakthrough alarm continuing to go off, you ignore it, you have about 1/12 of the filter lifetime to change the filters, and you'll be at 50% of TLV or lower. And then I know sometimes it's hard to fill out that chemical questionnaire in the very beginning, but there is a short list of chemicals that aren't recommended with carbon filtration. And typically it's anything that's gaseous at standard temperature and pressure. It's just going to be too light to pass, and it's just going to pass through the carbon. It's not going to adsorb to the carbon on the molecular level. And then any applications that you would need a specialty ducted fume hood for, such as a perchloric acid hood. You need a wash down hood so you don't have explosive crystals. A radioisotope hood has to be specially aligned to protect against radiation. And then anything that's immediately lethal or extremely toxic. Mercury, although well retained, is extremely toxic and it's difficult to detect breakthrough. And anything, if you have an SDS of anything that says fatal if inhaled, we're not going to recommend you use that in our ductless fume hoods. Now, how do we comply with the current laboratory standards? Well, ANSI Z95, the 2022 version, fully incorporates ductless fume hoods, and you're going to see a common theme here. 2 layers of filtration, so that's having those backup safety filters. Automatic breakthrough detections, having those solvent or acid sensors on the hood. Detailed application review, that's that chemical questionnaire, filling it out. And then for each chemical user retention capacity shall be known. So it's all that testing we've done with that chemical listing. We're able to give that to you. And now you'll see NFPA 45, the 2024 version, has the same basic principles. It incorporates ductless fume hoods with the safety layer of redundant filters, automatic detection of filter breakthrough with an audible and visual sensor, the detailed application review, again, this is that chemical questionnaire, and then a published chemical list with capacities. So we're fully compliant with the current laboratory ventilation standards. Now we're going to get on to how you can reduce your upfront costs and operating expense costs moving forward. So on this slide, you'll see this is how labs are traditionally designed. So this lab building would have 10 ducted fume hoods. Now take a look at the size of the chiller and the boiler in the basement, the air handling unit on top of the building, along with the exhaust fans and the cooling tower. And even look at the size of the ductwork. So these are 100% traditional ducted design. Now let's say you looking to reduce your upfront costs and your operating expense. Well, maybe you can replace half of the ducted hoods with ductless hoods. So in this example, you look at all the hoods where there were multiple hoods in there. If you have too many ducted hoods in a small space, you're going to overventilate the space because of the required makeup air. So adding ductless fume hoods once you reach that minimum air change rate significantly will save you significant amounts of energy, but also in the initial design, it's going to allow you to have smaller mechanical equipment, reduce the overall size. So you can see the size of the chiller and boiler in the basement, much smaller. There's one less exhaust stack on top of the roof. The air handler and the cooling tower are smaller. And also even the ductwork, the supply and return ductwork can be smaller. So you can save significant upfront costs on new construction with ductless fume hoods. Now, as a real-world example, Framingham State University here in Massachusetts was building a new science center back in 2015. When they received funding from the state, there was going to be a shortfall, so they weren't going to be able to build the top floor of the building. So they had to value engineer the product the project. So they looked, where could they save money? They looked at the fume hood. So they had a bunch of teaching labs in there where they're going to be 8, 6, or 3 hoods. They thought if we could replace all those ducted fume hoods in the teaching labs, are going to be a high density of fume hoods with ductless, we can have a significant upfront cost saving. So although the ductless fume hoods are about twice the cost of the ducted fume hood, that's because with the ductless fume hood, everything you need is included. You have the filters and fans right there. You don't need any infrastructure. By going with the 49 ductless fume hoods, they're able to reduce their air handling units by 18,000 CFM, which is a significant amount of money. And also, they'll be able to reduce their building ductwork by 36,000 pounds, saving almost $350,000. So overall, when you look at the premium of the ductless fume hoods versus the reduction of mechanical equipment they were able to get rid of because they weren't going with the 49 ducted fume hoods, they're able to save about $330,000 on the entire project and get the top floor of the building built. Now, this is a picture of the one of the 8 hood teaching labs there. So if you are installing fume hoods, say on an island or depending on where they are in the lab, take into consideration the views. You may want to put a clear glass panel on the back, side panels with glass, just so there increases visibility. Framingham State, we're actually there this summer doing their second filter change that was installed in 2016. And they're saving about $24,000 a year in operating expense in just the makeup air in these, especially these high-density fume hood labs. Now, the next example is Butler University. This was one of our first large projects with our green fume hood back in 2011. They had 2 5-hood chemistry teaching labs, which did not have enough hoods for all their students. They had HVAC capacity problems, so they had poor indoor air quality within the space. So they're hoping they get up to 26 total fume hoods from the 10 they had, so 5 in each lab. So they looked at going to ducted. And if they were to go with 26 ducted fume hoods, they were going to have to upgrade their entire HVAC system for a lump sum of about $350,000. So they looked, how could they do that for less money? They looked to ductless fume hoods. Although there was a premium again for the ductless fume hood versus just the ducted fume hood, they saved a significant amount of money by not having to upgrade their HVAC system. So overall, they're able to save about $66,000 in CapEx. And then also, one of the more important things was they were trying to get this done over the summer. They were able to get it done 3 months faster, so they did not miss classes in the fall. If they had gone with the complete upgrade with the whole HVAC system, it was going to take 3 months longer. Now, if you look at the next slide, this is how the ductwork, all the HVAC looked with the current 10 ducted fume hoods between the 2 labs. After they installed the 26 ductless fume hoods and had the renovation, this is what the ductwork looked like. So it significantly simplified the amount of ductwork needed. And then since that was 2011, we do have 10-year operating costs. So they were changing the filters every 4 years. So versus running 26 ducted fume hoods, they had a constant volume system, so they were going to all be at 744 CFM the whole time. They were going to cost them about $96,000 a year. With the ductless fume hoods, they were changing the filters every 4 years. So even with the cost of filter changes, they saved about $500,000 over the course of the 10 years. And then the next slide is a picture of the original lab. So you can see the green fume hoods on the outside, and then they actually use our capped air ductless fume hoods as equipment enclosures for their rotovap enclosures, just to eliminate any vapors that are released in the lab and improve the overall indoor air quality. And when Butler had a whole new science building built in 2021, they went with an additional 37 green fume hoods and another, I believe, 12 capped air ductless fume hoods. So now I want to talk about these high-density fume hood labs. How do you reduce your operating costs? So if you look at this slide here, this is going to be a 40 by 40 lab, so 16,000 cubic feet with 5 ducted fume hoods. Typically what we see most of the time, the hazard risk analysis will keep the required minimum air changes to 6 occupied, 4 unoccupied. So if you design this lab with 5 ducted fume hoods, even if they're VAV, variable air volume hoods, you're going to have to design it for worst case scenario. So 6-foot hoods would be about 750 CFM. So with each of them being on and operating, you need about 3,700 CFM to run that lab, which is going to equate to about 14 air changes per hour, which is 8 air changes per hour more than is needed. So that means in the summer, you're blowing out all that more cool conditioned air. In the summer, that warm conditioned air will be blown out as well. You have to have more makeup air, so that gets very expensive. But in this example, when you change 5 of those with those 5 ducted fume hoods, you go with 4 ductless and 1 ducted, you're going to significantly eliminate the amount of makeup air needed. So you can stay at the minimum air change rate within the space, because that 1 ducted fume hood is only going to be at 3 air changes per hour. And with this example, you'll see they save about $6,000 a year in operating expense, and that's just in the makeup air. And you'll see an even bigger savings if you go to a larger lab with 12 hoods. So in this example, all 12 hoods, we do see this with chemistry teaching labs, all being ducted. You're going to need about 9,000 CFM of air. So in that same size space, it'd be about 34 air changes per hour, about 28 air changes more per hour than you actually need. Now in this example, let's go with 10 ductless and 2 ducted. So those 2 ducted will keep them below that minimum air change rate, but also provide a hood for dispensing and hoods for satellite waste accumulation. So when you do that, you wind up seeing a significant savings of about $24,000 per year. That's with 35% usage. So with those hoods just being open 35% of the time, or being used 35% of the time with the sashes open, pulling 750 CFM each. Now, if you look at the operational carbon footprint, when you compare over the 20-year lifespan of a ducted fume hood versus a ductless fume hood, you're going to see about a 94% reduction in the overall carbon footprint. And a majority of that has to do with the gas and electricity needed for that makeup air. Because when you're using a ducted fume hood, whatever is being exhausted out that ducted fume hood into the outside world, you're going to need the appropriate makeup air. So in those high-density fume hood labs, that's where you're going to see this significant energy savings. Now, another real-world example is Bristol Community College here in Massachusetts. They were building a new science center back in 2014. It was originally designed as a high-performance building, which in Massachusetts would be a LEED Silver Plus with 18 ducted fume hoods. Funding was not immediately available from the state. In the interim, the president of the college signed them up for the 2050 Zero CO2 Challenge. But when funding did become available from the state, they weren't going to be able to meet the 2050 Zero CO2 Challenge with the original design with the 18 ducted fume hoods. So they saw that ventilation was the biggest energy user in the building. So they thought if they could decouple conditioning from ventilation, they'd be able to have a significant energy savings. They also thought if we could have an air quality monitoring system, we can probably keep all the labs at 4 air changes per hour occupied, 2 air changes unoccupied. Problem was, if they had the 18 ducted fume hoods, they had 2 5-hood chemistry teaching labs. You saw from the previous example, that's going to be about 14, 15 air changes per hour. And they were like, we need to go ductless. And by going ductless, they were able to eliminate 1 complete air handling unit. That high performance design had 3 air handling units with 70,000 CFM of capacity. With the zero net energy design, with the 13 ductless fume hoods and the 4 ducted fume hoods, they're able to eliminate 1 air handling unit for a total of 2, a capacity of 24,000 CFM, allowing them to reduce their hourly air changes by about 67%. So on their path to zero net energy, if you look at the energy use intensity, the original high performance design was at 230 EUI. The biggest reduction was in the ventilation category, which the ductless fume hood played a significant part. They were able to reduce it by 120 EUI. The way they got down to zero net energy is they have a 3.2 megawatt solar array completely covering a parking lot on campus. That original high performance design with 18 ducted fume hoods was going to use up over half of the energy on that solar array. The zero net energy design with the ductless fume hoods allowed them to only use about 20% of that. So where do ductless fume hoods fit? Basically everywhere. We're in just about every industry. Our most common, obviously, education, academic labs, analytical testing, where they're doing the same procedures over and over. But we're in pharma, biotech, petrochemical labs, flavor and fragrance, aerospace, startups. They're great as equipment enclosures for rotovapes, 3D printers, HPLCs, balances, or very low turbulence fans in our units, so you can be very accurate with your weighing. So the other place to think about is if you have any specialty engineered spaces. I touched on clean rooms earlier, but with clean rooms, you have 20 to 30 air changes coming into the space through HEPA filters. You don't want to put a ducted fume hood in there because clean rooms are supposed to be positive pressure to keep the particles out. It's hard to put a ducted fume hood in there. So a lot of cases, you'll see people using chemicals in the open in a clean room without protection. Having the ductless fume hood with the HEPA filters on top, you keep the particle count integrity of the clean room, and you keep that clean conditioned air in there. Another big application for us is in battery labs. You have very dry, humidity-controlled chambers in those labs. And again, if you have a ducted fume hood in there, you're taking all that dry, conditioned air and throwing it outside. So you can have a ductless fume hood in there with HEPA and carbon filtration for the powders and liquid chemicals they're working with, and keep all that dry, conditioned air within the space. And I want to thank Delia for setting this up. Again, I'm Tim Campbell. If anybody has any questions or would like to further discuss after this, please feel free to reach out. Happy to do a presentation tailored to your lab, and we can go from there. Thank you.
Thank you so much. Thanks, Tim, for your time today and your important research. Before we go, I would like to thank our audience for joining us today and remind all of you to head over to the Network Lounge to ask any questions that you may have now to our experts in our Meet Your Expert space. If you attended our speed networking session before this webinar, you will also, of course, be entered into the drawing for a $200 Amazon gift card, which will be announced at the end of the Meet Your Expert sessions. This webinar will also be available for on-demand viewing after the event here within the virtual event. Questions submitted during the on-demand period will be addressed via the contact information that you've provided at the time of registration. So until next time, we again thank you for joining us. Take care, everyone. Bye-bye.